Dear friends, welcome back to the electronics world. This is lecture number 6. In this lecture, we are going to study about modern atomic theory powered by Bohr's atomic model. But before that, let's recap some of the vital points that we had come across in our lecture number 5. In our lecture number 5, we studied about an experiment conducted which is known as alpha scattering experiment. The scientist Ernest Rutherford had conducted this experiment to discover nucleus. The experiment was something like this. He took a radioactive element and put it inside a lead box or lead chamber. That lead box or lead chamber was having a thin slit through which the alpha particles could come out. A detector was suitably placed so that the alpha particles coming out of the lead box could easily strike it. As the experiment was conducted, it was found that all of the alpha particles struck the detector present. Next, he introduced a thin, very thin gold foil on the way of the alpha particles, and to his utter surprise, he saw that some of the alpha particles reverted back and some exactly back scattered, indicating that a something very heavy is present inside the atom, which occupies very less space inside the atom. So Rutherford gave his model. He proposed his theory, which indicated that most part of the atom is empty, and there is something present inside the atom which is centrally located and which is having positive charge, that was named as nucleus. Then he proposed his theory that nucleus is at the center of the atom and the electrons are revolving around it in circular paths known as cell or orbit. However, the question arises is that because the electrons are revolving around the nucleus in circular path and they are having a constant velocity, then they should accelerate, and if they accelerate, they should emit energy in the form of electromagnetic wave. They should radiate energy in the form of electromagnetic wave, and as this process continues, they should lose energy and ultimately fall into the nucleus. But does that happen really? No, it never happens. And why it does not happen could not be explained by the scientist Ernest Rutherford. Can we say that this model was altogether wrong? No, it was not wrong at all, but it needed some modification, and that modification was provided by another scientist, Niels Bohr. Okay, so we'll study about atomic theory proposed by Niels Bohr. The theory proposed by Bohr is commonly known as postulates. In the first postulate, he said that nucleus is present at the center of the atom. Indeed, this was the theory proposed by Ernest Rutherford. The second postulate is important point. The second one, electrons revolve around the nucleus in certain path known as cell or orbit. If we go back to our Rutherford's model, Rutherford said that electrons revolve around the nucleus in circular path, but he told Bohr's atomic suggested that in certain fixed paths which is circular in nature, we can say circular path. So let me explain you the difference. Suppose that this is the nucleus and so this is one orbit, this is another orbit, and this is my nucleus. Rutherford said that electrons can revolve in any circular path, not necessarily this circular path. It can be, let me say, this may be the path for electron, this or maybe the path for the electron. So the electron can take any path as per its wish, but it has to take a circular path. But the circular path is not fixed. But Bohr said that no, the electron cannot move in arbitrarily. They have to follow the circular path, but they are also fixed in nature. That cannot be changed. So let me say, if the electron is moving in this circular path, then it will move in this circular path. If the electron is moving in this circular path, it will move in this circular path. So this circular path is fixed. It cannot be changed. Okay. So let us come to the next postulate. The next postulate says that it is about the quantization. So the quantization theory says that the electrons revolve around the nucleus in those circular orbits for which angular momentum is an integral multiple of h by 2 pi. That means the electrons, they can revolve in those circular orbits for which angular momentum is an integral multiple of h by 2 pi. So what does that indicate? So the electrons revolve around the nucleus in those circular orbits. So let me say this is a circular orbit or this is a circular orbit for which angular momentum, so angular momentum is an integral multiple. Integral multiple means it is an integer. So integral multiple, that means integral multiple of h by 2 pi. So what is our h? H is nothing but a Planck's constant. So let me denote this angular momentum by L. So if L is the angular momentum, then is the angular momentum. Then L is equals to h by 2 pi. H by 2 pi, where h is the Planck's constant. Okay. So that means, so what is our L? Suppose that this electron is revolving in this circuit, in this path, in this path with a velocity v. So if v is the velocity of the electron, m is the mass of the electron, then and r is the radius. So this is the radius, or you can say the distance of the electron from the nucleus. So r is the distance, or you can say, because the electron is revolving around the nucleus in circular path, you can say that it is the radius of the radius of this circular path. Then we know that our angular momentum L is equals to mvr, and because L is equal to mvr and L is also equal to h by 2 pi, so mvr, so our mvr should be equals to nh by 2 pi, where n is an integer, because we have already told that the electrons revolve around the nucleus in those circular orbit for which angular momentum, so this is our angular momentum is an integral multiple, so this is an integer, so integral multiple of h by 2 pi, where h is the Planck's constant. So that means this m here should be an integral multiple of h by 2 pi. That indicates if our n is equal to 1, then m here is equals to h by 2 pi. So if n is equals to 2, so m here is equals to 2h by 2 pi. So n equal to 3, m here is equals to 3h by 2 pi, and for n is equals to 4, mvr is equals to 4h by 2 pi. So that means this part, this is 1h, so this part should be an integer, it is the value of n. So that indicates that this cannot be a fraction. We cannot say mvr is equals to 3.5 h by 2 pi. No, we cannot say, because we cannot have, it is not an integer. So the electrons revolve around the nucleus in those circular orbits for which angular momentum is an integral multiple of h by 2 pi. Okay. So if our n is equals to 1, if n is equals to 1, then this particular cell is known as K. If n is equals to 2, this particular cell is known as M. If n is equals to 3, this particular cell is known as, this is L. For if n equal to 2, particular cell is known as L. For n equal to 3, particular cell is known as M. And if our n is equals to 4, then this particular cell is known as N. So this is known as our quantization theory, which was given by Niels Bohr. So the fourth The fourth postulate is that when the electron revolves around the nucleus, in certain fixed path, known as orbit, it experiences a centripetal force This is because the electron is revolving around the nucleus in certain circular path. If a body revolves in a circular path in constant velocity, then it actually experiences a force as if it is being attracted by something which is placed at the center of the circle. And because the electron is revolving around the nucleus, and so it experiences centripetal force as if the nucleus is attracting the electrons. So this is known as our postulate number 4. Okay, so let us come back to our original theory. Why the electron which is revolving around the nucleus in certain in the circular path does not fall into it. Electrons are revolving around the nucleus in certain path. They should radiate energy in the form of electromagnetic wave, and ultimately they should fall into the nucleus by losing energy. So here this second postulate comes into picture, because it indicates that electrons revolve around the nucleus in certain fixed path known as cell or orbit. So that means, suppose that this electron is in this path, then this path is fixed for this electron, and this electron possesses some amount of energy associated with this cell only. Because suppose that we will consider about this electron. This electron is in this path, or it is in this orbit. That means that this electron should remain in this orbit for till the time it possesses the energy of this cell. So the energy possessed by this cell is different from the energy possessed by this cell. So as we go up, the amount of energy possessed by the cell increases. So that means the energy possessed by this cell, ultimately by the electron which is present in this cell, is less than that of the energy possessed by this cell. So let us consider this electron. This electron is revolving around the nucleus in this path, or you can say it is in this orbit. This particular orbit possesses some amount of energy, and the electron revolving in that in this particular orbit does possess the energy of this cell only. Okay, so till now we could know that this electron has some amount of energy associated with this, with it. So another electron, let us consider this electron. So this electron is in this orbit, so it is also having some amount of energy, but one thing we have to remember: if we go up, that means if you go from cell number 1 to cell number 2, or 2 to 3, so as we go higher in the order, the energy possessed by the cell increases. So that means the energy possessed by the electrons also increases, which are revolving in those particular orbits. Okay. So that means the energy possessed by this electron is constant. So whatever may be the number of electrons revolving in this particular orbit or cell, it is constant. And the energy possessed by this electron, or else we can say all the electrons revolving in this cell have the same amount of energy. And suppose, so that is why, because they have this amount of energy, so they cannot come out. So if this electron wants to come to this orbit, then it must gain some amount of energy so that it can jump from first cell to second cell, from this orbit to this orbit. Okay, so suppose that let us consider this electron, if it wants to come to this cell, then it has to radiate some amount of energy, which is so the difference being the so it has to radiate some amount of energy. So the value of this energy is the difference between the energy possessed by this orbit and this orbit. So so that indicates that the electron has some amount of energy associated with it, and as long as it has that amount of energy, it cannot deviate from its path. It cannot go to arbitrarily from one orbit to another orbit. So for that to happen, it has either to gain energy or lose energy. So because that is not happening, so you can say that this electron never falls into the nucleus. Okay, so that was the solution given. So our modern atomic theory is not only about our Bohr's atomic model, but principally it is due to the Bohr's atomic model, which is the subsequent result of our Rutherford's model. But other scientists have also a role in it. So you can go back to my previous videos to know about the inception of the theory of atomic inception of the atomic model. Theory is related to atomic structure. Okay, so our modern atomic theory, my dear friends, so let's come and study what this modern atomic theory is all about. We all know that the explorations by the scientists, or the hard work by the scientists to discover what atom is not new. It started centuries back with Dalton coming for the first time. John Dalton came with a significant approach towards the study of atomic structure. Then it was followed by scientists J.J. Thomson, Ernest Rutherford. Finally, the final touch was given by Niels Bohr. Okay, so what this modern atomic theory is? Modern atomic theory is about the structure of an atom. What the atom contains? The atom can mainly be divided into two parts. They are nucleus and extranuclear part. So let us come and study about nucleus. From the alpha scattering experiment, we all know that atom is located centrally. That means the atom is located at the center of, the nucleus is located at the center of an atom. What is the net charge of the nucleus? It is positively charged because it contains two subatomic particles known as protons and neutrons, and the proton is positively charged, neutrons do not have any charge. So we can say that nucleus this is positive, so these are positive and these are zero charge, that means neutral. Zero charge or neutral. Something which is neutral does not have any charge. Okay, so that's why net charge of the nucleus is always positive, because if we add a positive number with 0, we will get that positive number only. So that means our nucleus is located at the center of the atom, so it is positively charged. Then what extranuclear part is? The extranuclear part is that part of an atom where nucleus is not present. In other words, we can say that if we negate the existence of nucleus from the atom, the remaining part of the atom is known as our extranuclear part. So let's say if this is an atom and the nucleus is present somewhere here, so if we suppose that the nucleus is present somewhere here, that means all the rest part of the atom is known as our extranuclear part. Okay, my dear friends. Dear friends, we all know that under ordinary condition, atom is electrically neutral. That means the net charge of an atom is 0. Okay, so but we have seen that there is something known as nucleus which is having positive charge. So nucleus is having positive charge. So that indicates that there must be some negatively charged particles that stood outside of the nucleus but inside of the atom, and which is negatively charged. Okay, so yes, that's true. And the subatomic particles present in the extranuclear part are known as electrons. The electrons are the subatomic particles which are present in our extranuclear part, and yes, these electrons are negatively charged. Okay, so what they do really? They revolve around the nucleus in certain path. Okay, so if this is our nucleus, then in certain fixed path, so let us say this is our nucleus. Okay, so this is the path which is known as cell or orbit, in which our electron revolves. So let me say this is an electron. So this electron revolves around this nucleus in this certain path which is known as cell or orbit. There can be a number of cells depending on the number of electrons an atom consists of. Okay, So what is the maximum number of electrons that a particular cell can contain? So that is given by a formula which is known as 2n square formula, where the maximum number of is given by 2n square, where n is the cell number. So I told you that there can be a number of cells. So let me say this is another cell. So let me say this is another cell. So these are the electrons which are revolving in the first cell. So this is our first cell. That means our n is equal to 1 over here. So this is our second cell. That means our n is equal to 2. This is our third cell. That means n is equal to 3. The maximum number of electrons the first cell can contain is equals to 2 into 1 square, because our n is equals to 1. So that is nothing but 2 into 1 is equal to 2. So similarly, the maximum number of electrons the second cell can contain is equals to 2 into 2 square, that is 2 into 4, 8. Similarly, the maximum number of electrons the third cell can contain is equals to 2 into 3 square, that is 2 into 9 is equals to 18, and so on and so forth. Okay. But there are some certain limitations to this theory, that the last cell of an atom cannot contain more than 8 electrons. Similarly, the last but one cell of an atom cannot contain more than 18 electrons. Suppose that an atom is having 4 number of cells. So according to our formula, that is the fourth cell of an atom should have contained 2 into 4 square, that is a 32 number of electrons. But since it is the last cell of an atom, of that atom, so it cannot contain more than 8 electrons. Okay. Similarly, the last but one cell of an atom, that means the cell which comes prior to, just previous to the last cell, that cell cannot contain more than 18 electrons. So these are the some limitations to this theory. Okay. However, the question comes, why this atom is electrically neutral? The answer to this question is because under ordinary condition we can say that the number of protons, that means our positively charged particles, is equals to number of electrons. And this is the condition due to which our atom under ordinary condition is electrically neutral. So what the subatomic particles are? The subatomic particles means the particles which are present inside an atom, and as we have already studied, they are nothing but our protons, neutrons and electrons. Okay. So then there is the concept of atomic number. Each atom has a single atomic number. The atomic number is nothing but the number of protons contained by that atom, which is nothing but number of electrons contained by that atom. Then atomic weight is equals to number of protons contained by that atom plus number of neutrons. Then there comes the concept of what our valence electron. So we have already studied that there can be a number of cells. So what is our valence cell first? So let us study about valence cell. The outermost cell of an atom or the last cell of an atom is known as valence cell. This is known as our valence cell. And what is the valence electrons? The electrons which are present in the outermost cell of an atom, they are known as valence electrons. In other words, the electrons which are present in the valence cell of an atom are known as valence electrons. So okay my friends, then what this valence electrons is? So we have studied that the valence cell of an atom can contain maximum of 8 number of electrons. So if the number of electrons in the valence cell if that is less than 4, that means which is equal to the maximum number of electrons that the valence cell can contain, that is 8 by 2, then that atom is either a metal or a conductor. Metal or conductor. And if the number of electrons in the valence cell is greater than 4, that means which is greater than 8 by 2, that means here that is our insulators, non-metals or insulators. Non-metals and, sorry, this is a metal and conductor, non-metals and insulators. So if it is equals to 4, that means they possess the property of both metal and non-metal, or else you can say they possess the property of conductors and insulators. They are known as semiconductors. So my dear friends, so we have come to an end of this lecture. If you have any doubts, any queries, you can write in the comments box. Thank you.